Okay, today we are going to start in our notebooks with a little bit of notes about proportional relationships. You guys learned this in 7th grade, but we're going to do a quick review on it. So a proportional relationship is one in which the ratio of the inputs and the outputs is constant. So we are talking about the proportional relationship here. So that means that it's going up at a steady rate. That's what we were talking about yesterday when we looked at the graph and the table. Proportional relationships are always written with this equation right here, y equals kx. Now, do you see how I highlighted it and I circled it? This is something that's really important, so you really need to make sure you have this in your notes. Go grab a highlighter and highlight it. Make sure that you know this equation. This equation represents where x represents the input value and y represents the output value and k represents some constant that is not equal to 0. If we had a 0 here, anything multiplied by 0 is 0, so it would negate the equation. So we don't want it to equal 0. Now we're going to talk a lot about k and what k represents. The constant k is called the constant of proportionality. You might have heard this some last year in 7th grade, maybe even in 6th grade. It's not a term that we're going to use very often, but it is a term that you should be familiar with. What we're going to call it is the rate of change. We're going to be talking about the rate of change quite a bit. So know that this k right here in our equation y equals kx, this k represents the rate of change. It also represents the coefficient. When we were learning about equations in 6th grade, we talked about the coefficient. The coefficient is the number that is attached to the variable, in this case the x. It is also the rate of change, and it can be a fraction or a ratio. So that means we could potentially have an equation that is y equals 1/2. Whoa, don't know what that did. Y equals 1/2 x. And that shouldn't worry you. Fractions aren't that big a deal to work with. Okay, so let's review what we talked about yesterday. You guys should have this in your note. So that means that we're going to now open your textbooks and we're going to go to that page 174. Yesterday, you guys took notes up until the last 2 questions. We really want to spend the time talking about those 2 questions today. So first of all, before we even talk about this, let's review. Daisha, we looked at her information in the form of a table, and we determined that because she drove 120 minutes in 2 hours, we were able to reduce that ratio down to be 60 miles in 1 hour. So that told us that she was driving 60 miles per hour. Now Tamar is 50 miles an hour. We were able to look at his graph, and remember his graph went up from the origin and continued at a steady pace, and we were able to look at his graph and see the 1 and follow it up to 50. So we were able to determine that his ratio was 50 miles to every 1 hour. Now up here we now have Alicia. So we are now talking about Alicia. Alicia offers to drive Daisa and Tamar home for spring break so that they can share the cost of gas money. When asked how fast she drives, Alicia reported that the distance traveled y for the time x is y equals 57x. So they are referring to that equation that we just talked about, that y equals kx. So they're saying that y is the distance and x is the time when we are referring to this, and k is going to be our rate of change, our miles per hour. So we don't even have to do any, I'm going to write it over here, y equals 57x. We don't even have to do any math to know that Alicia is driving 57 miles per hour. And her equation is y equals 57x. So we know because there is no other numbers over here, that this is a constant, or a proportional relationship. A proportional relationship. Now, we can write equations for Desa too, because we know that she was driving 60 miles an hour. So her equation would be y equals 60x, where y is the distance and x is the time, just like up here. Tamar was driving 50 miles an hour, so his equation would be y equals 50x. Okay, so the first question here asks, does Alicia's equation represent a proportional relationship? Yes, it does. She is going up at a steady rate, so we can just put yes there. Now, we want to talk about who drove the fastest. So remember, we had Desa that drove 60 miles per hour. We had Tamar who drove 50 miles per hour. And now we have Alicia who drove 57 miles per hour. So Desa is still the fastest driver in her little friend group. So she is the fastest. And we can also rank the friends in order from the slowest to the fastest. So Tamar drove 50 miles an hour. So he is the slowest driver. So we have Tamar at 50 miles per 1 hour, or y equals 50x. Then we have Alicia that drove 57 miles per 1 hour, or we can say y equals 57x. And then finally we have Desa who drove 60 miles per 1 hour, or we can say y equals 60x. Now, today you are going to be going on and doing an assignment. So as you're writing these equations, make sure you keep that equation that we wrote and highlighted in mind of the y equals kx. This will always be your input, this will be your output, and this will always be your rate of change. That was what, when we had the chart, we were finding the difference. That's what we were finding, was that difference right there.